Venus is the most terrifying planet in the solar system, and almost nobody talks about it. Everyone obsesses over Mars. Mars gets the rovers, the headlines, the billionaire colonization plans. But Venus? Venus is what happens when a planet dies. And understanding how it died might be the most important scientific question of our century. Because Venus is a warning about what could happen to Earth. 3 billion years ago, Venus might have been paradise. NASA climate models suggest that ancient Venus had liquid water oceans, moderate temperatures, and a relatively thin atmosphere. If you could go back in time and stand on the surface, you might see something eerily familiar. Blue skies, clouds, waves lapping against shorelines. It might have been habitable for longer than Mars ever was. Some scientists believe it could have supported life for over 2 billion years. Then something went catastrophically wrong. The leading theory is a runaway greenhouse effect. As the sun slowly brightened over billions of years, Venus's oceans began to evaporate. Water vapor is a potent greenhouse gas, so more evaporation meant more heat, which meant more evaporation, which meant more heat. The feedback loop spiraled out of control. The oceans boiled away entirely. Without liquid water, carbon dioxide could not be absorbed into rocks through a process called the carbonate-silicate cycle, which is Earth's natural thermostat. All that carbon dioxide accumulated in the atmosphere, trapping more and more heat. Today, the surface of Venus is 875 degrees Fahrenheit. That is hot enough to melt lead. The atmospheric pressure at the surface is 90 times that of Earth, equivalent to being half a mile underwater. The atmosphere is 96% carbon dioxide, and the clouds are made of sulfuric acid. It rains sulfuric acid on Venus, but the rain never reaches the ground because it evaporates in the extreme heat before it can fall more than a few miles. The surface is a hellscape of volcanic plains, crushed and cracked rock, and a permanent orange haze that blocks all direct sunlight. The temperature is essentially the same everywhere on Venus: dayside, nightside, equator, poles. The atmosphere is so thick and so efficient at distributing heat that there is virtually no temperature variation across the entire planet. Soviet Venera landers sent back photographs in the 1980s before being destroyed by the conditions. The engineering required to survive on Venus, even briefly, was extraordinary. The landers were made of titanium and had to be pre-cooled before entry because the heat would begin destroying components the moment they entered the atmosphere. They survived between 23 minutes and about 2 hours. The images they returned show a flat, rocky wasteland under a dim, oppressive orange sky. The rocks appear sharp-edged and relatively young, suggesting active volcanism. No spacecraft has survived longer. And here is why this matters for you, sitting on Earth right now. The mechanism that destroyed Venus, a runaway greenhouse effect driven by accumulating atmospheric carbon dioxide, is the same mechanism that scientists warn about when they discuss climate change on Earth. Now, to be absolutely clear, Earth is not about to turn into Venus. We are nowhere near that tipping point, and our planet has powerful stabilizing mechanisms that Venus lacked, most importantly, our oceans, which act as a massive carbon sink. But the physics is the same. Carbon dioxide traps heat. More carbon dioxide traps more heat. And there are potential tipping points in Earth's climate system: thawing permafrost releasing methane, dying forests releasing stored carbon, melting ice reducing the planet's reflectivity, that could trigger feedback loops. Not Venus-level feedback loops, but significant ones. There is also an unsettling mystery hovering in the Venusian clouds. In 2020, astronomers announced the tentative detection of phosphine gas in Venus's upper atmosphere. On Earth, phosphine is primarily produced by anaerobic bacteria, organisms that live without oxygen. Its presence on Venus, if confirmed, could suggest microbial life existing in the cloud layers, where temperatures and pressures are actually quite Earth-like despite the hellish conditions on the surface. The detection remains controversial and is being investigated by follow-up observations. But the idea that life could be floating in the clouds of a planet whose surface can melt metal is a profound one. It means that even after a planet's surface becomes completely uninhabitable, life might find a way to persist in the atmosphere, clinging to existence in the only remaining habitable zone. Venus is proof that a planet in the habitable zone of a sun-like star, a planet with oceans and moderate temperatures and possibly even life, can be transformed into an uninhabitable hellscape through atmospheric chemistry alone. No asteroid required, no cosmic catastrophe needed, just a slow, steady accumulation of heat-trapping gases and an inability to pull the brakes. Every time we send a probe to Venus, we are not just studying another planet. We are studying a possible future. A worst-case scenario written in sulfuric acid and 800-degree rock. Venus is Earth's evil twin,